Hi, I am Gagan, and this is a short walkthrough of my submission for the Vexa AI CognoDB benchmarking assignment. The main goal of this project was to compare CognoDB Cloud with other graph databases using the same dataset, similar resources, and the same logical workloads. I focused mainly on the three things: fairness, reproducibility, and honest reporting. Let's first review our project. And this is a project, a Python based benchmark suite. The idea is simple. We load the same graph database set into each database, run the same type of queries, and collect the latency and throughput numbers, and then compare the result. And I have kept the project intentionally simple so that the complete benchmark flow is easy to understand and reproduce. Let uh, see our benchmark and adapter folders. Here are the our benchmark folder. Here our configuration files comes. Here it loads the dataset files into the RAM. Here the matrix function summarize. Through this it run all the runner workloads, and here the adapters comes. Let's like we are using arrange.db, so here is the code for the arrange.db, and for all others also, all the adapters, here the codes come. And we run benchmark.python file, so we can get our whole data, right? Let first see how our data comes. Data selection. Uh, for the benchmark, I use a public graph dataset with more than 1 lakh relationships. I prepare the dataset once and use the same logical dataset across the databases. The README contains the exact data source, node count, relationship count, and the pre-processing step. Let me show you the datasets. Here, dataset uh, comes from the Stanford education data we use, and in the database setup, I benchmark CognoDB along with four other graph database platforms. For each platform, I documented the available diet and CPU, memory, storage, and reason. Resource parity was important here because comparing a free tier instance with a much larger instance would not be fair benchmark. Where exact resource matching was not possible, I documented the difference and treated it as a limitation instead of hiding it. Benchmark workloads. The benchmark cover the main workload mentioned in the assignment. For transversal, I tested one hop, two hop, three hop queries using randomly selected starting nodes. I also tested point lookups, indexed or filter lookups, or an aggregation query. For the real workload, I first run warm up queries and then perform the actual measurement, and each workload is repeated multiple times, and I report P50 and P95 latency instead of only reporting the average. This is important because the average alone can hide slow request and performance variation. This is the methodology I have used. Mixed workload. Let's see, I also included a concurrent read write workload. The benchmark run multiple clients with a defined read write mix and measure the substance query per second. I also track queries per second, successful request, failed request, and timeout, so that the failure are not hidden from the final result. The benchmark code is separated into the database specific adapters and the common benchmark logic. The common benchmark logic handles things like warm up, iterations, latency, measurement, percentile calculation, and the result collection. The database adapter handle the platform specific connection and query execution. This allow the same benchmark logic to be reused across the different datasets. And let's talk about the configuration and the security of this. All database credentials, connection details, and ports, other runtime configuration are loaded through environmental variables. The actual .env file is not committed to the GitHub. It have included an .env.example file so that the another developer can understand what the configuration is required. This is the chart we can see from the different different data sets that we record. The benchmark generate machine readable results in JSON or CSV format. I then use Python to generate charts from the actual benchmark result. The chart show things like transfer cell latency, lookup latency, ingest throughput, and mixed workload throughput. The README contains the complete result matrix along with the charts and methodology. One thing I analysis that I wanted to avoid was simply saying that one database is the winner. The result depend on the workload and the available resources. So instead of making a general claim, I have explained where each platform performed well, where it struggled, and what could explain those differences. I have also documented platform limitation, network effects, and free tier restrictions, and any benchmark that could not be measured. Right? This is the our whole analysis part comes, and it is the limitations, and it's the reproduction how another developer can use. It is our repository structure, right? Overall, the main focus of this project was not just collecting numbers; it was building a benchmark that someone can else can reproduce, understand, extend. Let me show you some benchmarks here also. Here it show the summary of our whole benchmark.